Live from the National Space Centre, it's the Mars Landing Watch Party. Hosted by speaker and strategist Mary Carty of Wilson and Keys, with special guests Dr. Niall Smith of Blackrock Castle Observatory and Dr. Niamh Shaw, RTE Space Hub presenter and award-winning communicator. They'll be chatting about some of your questions on space, Mars, and the Mars Perseverance rover landing on the Red Planet just 1 hour from now. The Perseverance mission is to find signs of ancient microbial life. Collecting rock and soil samples, we hope, will show this. After its almost 7-month journey, tonight the Mars rover will plunge through the thin Martian atmosphere, heat shield first, at a speed of 2,000 kilometers per hour. As it approaches the planet, a parachute will slow the rover down and a sky crane will lower Perseverance into Jezero, the crater scientists believe once created a lake. So now, get your lime landers and your Mars bar melts ready, and let's join our panel to find out more about what's about to happen on Mars.
Hello, are people here already?
All right, I think we might kick in. We got lots and lots of fantastic questions for everybody here today, and I think we might start. What do you think? Niall, I might start with you.
Yeah,
Is that okay?
absolutely, Mary.
Niall, how long did it take to build that probe? Because it looks really fantastic.
Yeah, it is. It's the most complicated piece of kit that has been put on Mars, or hopefully, well, will be put on Mars tonight, one way or another. So technically, they started about 7 years ago in the real design stage, but prior to that, there was about another 7 years where you had the concept. You had a bunch of people sort of competing as to what they should do, because if you're going to spend sort of the whole probe thing costs about 2 billion. If you're going to spend 2 billion on getting to Mars, obviously you're going to want to get the best ideas, throw them around, figure out what is the best of the best ideas, and then you start building the project. So it was really, so it's been already at least 14 years, but even prior to that, because it's such a good question, you had the previous landers, you had Spirit, Opportunity, you had the Viking landers back in the 70s, which started all of that. So they brought a whole load of learning about Mars, things we understood, things we didn't understand, technical challenges, like it's very cold but really windy. It's a really dusty place, and dust can play havoc with instruments and so on. So we learned a huge amount really over the last 40 years or whatever. So although Perseverance has been in the making maybe for the last 7 years, it's really based upon something which has been going on for sort of much closer to sort of 40 years. And if you include the Russian probes prior to that went into orbit, you're going back even further again. These are not things that you do overnight. I have to say, these are long-term life goal missions that you get involved with, and that's why it's so exciting tonight. All that effort, all those years of preparation, and very close now.
That's a lot of brains and a lot of people and a lot of collaboration from many countries all working together to make this happen. That's just so exciting and fantastic, isn't it?
It's a great example of when people work together. You know, we think of lots of bad things going on in the world, but this is a real good example of us all just working together because we want to find out stuff we want to explore. And yeah, it's the best of humanity is what got together to put this lander on Mars tonight.
And I think we kind of need that hopeful message right now. So that's really, really good. And I suppose following on from that then, Niamh, what is the difference between this mission, Perseverance's mission, and the previous Mars rovers? Because as Niall said, there's been many. What's the difference?
Well, I think the main difference, and the one that's really exciting about this one, and Niall will, I'm sure, jump in and tell us more, is that this is a mission where they're going to collect samples, and not just like dust samples. They're actually going to collect like blocks of sort of like chalk drills, and the point is, and the hope is, that they'll actually be returned to Earth. So not only will there be testing in situ on site, the next following mission in partnership with ESA, they're going to be bringing back samples. That's really, really really exciting. Perseverance has been designed for many, many reasons, but it's got way more cameras on board. It has microphones. For the first time, we're going to be able to hear the sound of a landing. So, you know, whenever we start getting data back, I've always wanted to know what Mars kind of like sounds like and what it sounds like when you land and everything. So they've got some really great cameras. They've cameras there just purely for outreach. They've cameras to kind of check if the landing is okay, and they've cameras for scientific. But it really is, it's a very involved kind of a rover. And the big thing is that we would be returning samples back to Earth, you know, so that's what's great about it.
That is very, very, very cool, I must say. And then, Niamh, what do you hope, or do you hope that maybe anything more unusual, or, you know, what would you like to be discovered? What do you think?
Well, I don't, like, it's hard to know, but I mean, obviously they're going there. They've picked this crater because that there is potential for ancient signs of like microbial life, and that's all based on previous tests and previous analysis of data collected from other rovers. That there's signifiers that the chemical reactions that happen in the presence of microbial life, there's presence of those chemicals there, which kind of hints at it. And there's all these sort of theories, you know, that there's this connection between Mars and Earth, that maybe there was this, you know, explosion or this meteorite or a piece of Mars that landed on Earth that kicked off life on Earth. Nobody knows. I mean, they're all theories, and who knows. What I particularly love about this particular Perseverance mission is that there's a tradition on a lot of equipment that's sent to space, that there's usually some sort of like extra little, what's called festooning. So there's always some little identifier on all the spacecraft that went out. But on Perseverance, there's 6 pieces of little kind of personal identifiers, and there's a lovely memorial to COVID that's on it. So they've put a little tiny plaque on it that has, you know, the medical sign. So that's like you know, a needle, and then you've got the snake around it, and then they have the sort of COVID sign, and that's to say thank you to everybody who has helped us progress at this stage, as well as to all the people that you know, that have been, you know, struck down by the pandemic. There's also 10.9 million names etched on the piece. Niall, is your name there? My name's there.
My name is there. My name is there.
And let's see, anybody who got the boarding pass, your name is there. So there's 10.9 million of us possibly landing on Mars tonight. But
and of course, Niamh, you can also put your name down for the next mission as well.
That's right. Yeah.
Well, so if anybody here hasn't put their name down,
put your name down.
Right. Yeah.
And Niall, what about you? What are you secretly hoping they're going to find?
Yeah, so I mean, one of the things that I love as a scientist is the unknowns and the things that you know. So in a way, you're going to say what I'm hoping for is something we really just didn't anticipate. So one of the big questions, and Niamh has put it very well, is we're really looking for forms of microbial life, because we kind of reckon that if it got that far on Mars 3.5 billion years ago, that's roughly what would have been happening on Earth 3.5 billion years ago. But what if Mars was ahead of Earth? What if it was slightly more sophisticated than microbial? What if we find something with legs or something like that? Very unlikely, but it's that type of, really, we don't know how evolution works. By the way, we've no idea if there was ever life on Mars, and we don't know what we're going to find. But for me, that's kind of interesting. Let's see whether there's something a bit more sophisticated. Or the other thing, Mary, would be that the type of life form, the structure, the way it was built is somehow fundamentally different, that we can recognize it somehow as something that's kind of biological, but it doesn't look, it looks Martian more than Earth. Now, it's going to be made of the same materials in some sense, because Mars and Earth are, you know, they're all made of the same. There's no magic stuff on Mars or whatever. But did life try to put chemicals together in a different way 3.5 million years ago? Did that fail? You know, so all of these are admittedly the far out questions. That's not the primary objective of the mission, but what if? And that, I think, is what makes us all really excited. It's the what ifs, because we really don't know how life got going in this universe. We've no idea.
We never know. We may find out then that human life on Earth could have come from Mars, maybe, because that was one of the questions that we had from one of our participants as well. So that's really cool. So you answered the question before I even asked it. That's pretty brilliant.
And the other thing, Mary, just there, like the thing that Niall said, is also there's also this notion that, you know, rivers would have once you know, flown on the surface of Mars and everything, and all that's gone now. So the other thing, of course, would be to try and figure out, if that is the case, what happened. and why did all that occur? So it's like what Niall says, we don't know, but there's secrets there. And what I love about science is, you know, you have these little pieces of information, and amazing scientists and engineers go away and analyze them, and from that they're able to surmise you know, what actually happened. So that's what's exciting about it, you know?
And a mission like this, or any mission, like, you know, you have some objectives you think you're going to meet, but there's the ones on the edge that the really kind of exciting ones, and the ones that really drive our understanding of the universe forward. And it's because you can't predict those that you have to do this fundamental basic science. So that's what this is doing as well. It's kind of a mix between, you know, something where we'll learn more about Mars for sure, absolutely, but then what else might we get? And that's kind of, both can be exciting, by the way, but having that little bit extra, whenever we would use telescopes to look at the sky and so on, we'd always have a mission as part of that, but there'd always be a bit of time you'd use to do a bit of something extra. Maybe you hadn't told the telescope allocation committee about, but sometimes they were the most exciting pieces of science.
And one other thing is the helicopter, like if it works, because that's a pretty good feat of engineering as well, because atmosphere is different. It's a lot thinner on Mars than it is here. But the helicopter, if it works, it means that we can get all these amazing aerial shots off Mars. So rather than waiting for the Curiosity and the Perseverance rover to do their 200 meters a day or whatever it is that they do, this is actually going to be able to take a huge overview. And like what Niall says, if they come across things going, they'll be able to go down and look in, and because there's a camera on that as well. So that's what's great.
Well, that brings me to another question that our wonderful people asked tonight about how much fuel is on the rocket, and how much of the distance do they think it's going to go during this mission?
Yes. So Niamh, we could take this, I think, but so first of all, because Mars is so much further away from the Earth, to power something like a Perseverance, it takes 110 watts. Now, if you're my age, that's like 3 light bulbs. You're young, that's like now 50 light bulbs, because we've got so much more efficient in the way we use our light. But your kettle, for example, is about 10 times more power that it uses. When you boil your kettle, you're using 10 times more power, 10 times more energy than Perseverance is using. So you need to generate that 110 watts. But the sun isn't bright enough to do that for you, not reliably. And also, if you get these dust storms on Mars, and we saw, unfortunately, that we lost one of the previous rovers because the solar panels got covered in dust, and it couldn't generate power anymore. So it's done with using nuclear power. So it's a plutonium, which is a piece of nuclear material, very carefully generated. It's wrapped in what they call iridium, which is another heavy material, so that if, for example, when they were launching Perseverance, as they did back in July, was it? I've forgotten now exactly when it was launched, in 2020, that if it crashed, that we would be protected. In fact, that has happened in times past, and the pellets have been recovered and reused in future missions. So we're very safe when we put nuclear materials up into space, that if anything bad happens on the way, that it won't be toxic for the Earth. So those plutonium, what happens with the plutonium very quickly, Mary, is the plutonium is radioactive. And one thing that radioactive materials do is they generate heat. And once you're generating heat, you can convert that heat into electricity. And of course, then that's what powers the motor. So the fuel is actually nuclear, but the motors are electric. So you take heat generated from the nuclear power, convert that into electricity, and like all in our electric cars and all the rest, we're all getting more familiar with these electric motors. That's what powers it. We think there's enough plutonium for 14 years worth of operation. Perseverance. Now, it's only scheduled for 2 years. So I always only ever say 2 years, and usually it goes on for a lot longer, because these are smart people who work very hard to keep their rovers working. So we think, 2 years, there's funding for 2 years, but the plutonium will generate enough power for well, the presumption is about 4.
And that brings me to another question, Niamh. I suppose all that hard work that's gone into building something as incredible as Perseverance, are they going to leave it there, or are they going to bring Perseverance back?
Well, firstly, yeah, the 2 years is Earth year. So that's like, that's a Mars year, right, Niall? So
Yeah,
that's like
that's
699 sols. So a sol is longer than an Earth day. So an Earth day is about 24 hours, and a day on Mars is, I think, 24 hours and 39 minutes and something seconds or anything. So, so that's 690 sols in total. And you were asking me what, Mary? Sorry, I just jumped in.
Back.
There's
Oh
two
yeah,
and twos in here.
no, it's the
No?
size of a car. Like it's a pretty big. I mean, it's a big thing. Like it's 3 meters long by over 2 meters wide by over 2 meters high. So that's kind of the length of a car. So no, it probably won't. It probably won't come back. None of them do really. They kind of just go. But like, look at Curiosity rover. I mean, Curiosity rover is still going. It was on a 2-year or 2 Earth year mission, and it's still going, giving us back amazing images of their night sky where we can see Earth in the night sky. So I wouldn't imagine that it would come back unless like
So then
Enterprise, unless like they set Enterprise sets up its own rent a rover on Mars, and you have to return it. It's part of the hire and the lease is that you have to return it to where you left it, or you just pay the fee to bring it
So
back.
then we keep our fingers crossed that it will keep going for 14 years and giving us
Yeah.
lots and lots of amazing data. So
Yeah.
Niall, tell me something. What is Ingenuity doing up there? What's that about?
So Ingenuity is this little helicopter that Niamh mentioned,
I love it.
and it's brilliant. So it sits in the belly of Perseverance underneath, and just does nothing as Perseverance falls towards Mars. And then what happens when Perseverance lands is in a few days or a few weeks, it depends on what happens with the engineering and whether Perseverance is working perfectly and all the rest. But Ingenuity gets dropped basically from underneath the belly of Perseverance, which then backs away. And if you have seen sort of, you can imagine a helicopter, but it's got 2 blades and they rotate in, well, I can't really do it with my hands. I don't know why I even started trying to do that, but the blades rotate, but they rotate significantly faster than the blades of a normal helicopter. And the reason, and Niamh has mentioned this, the atmosphere on Mars is actually only about 100th that it is on the Earth. And in fact, that's the equivalent of flying twice as high as a normal jetliner. Now, the problem there is that if a helicopter needs to push on air molecules, let's say. So if there's very few of those molecules to actually push on anything, you have to rotate very, very quickly. So these things spin very quickly. So what NASA is hoping to do with ESA and everybody else involved in the project is try to see, first of all, can they actually get this thing to fly?
Yeah.
It hasn't been done before. So this is an absolute first. And of course, if you can get this to fly, as Niamh so eloquently put it, you can then fly over things in a simple sort of hop, which will take you weeks, months, maybe even, and you could get stuck on rocks and all the rest. So, we've all become so familiar with drones. This is effectively a Martian drone. That's exactly what it is. It carries, I think it's interesting, it carries a 13 megapixel camera.
Ooh.
It's effectively a camera you'd have on your mobile phone. So
Wow.
it's phone
Yeah.
stuck on a helicopter and brought to Mars. But that's great, because actually what that means is to develop that particular camera and then an Ingenuity, it's not so expensive. Ingenuity is relatively cost effective. And so we're now starting even to think, okay, if we're going to start to bring lots of stuff to Mars, can we start to build stuff even less expensively? So that's also part of what's being tested now. It's a little bit what they call, it's not quite, but it's called components off the shelf. So components that already exist. So what we hope to do is get a bird's eye view of Perseverance, of the tracks. And actually, again, Niamh mentioned this, but anytime you take a picture, of the tracks, it tells you something about the sand or whatever. So the scientists will be delighted to see pictures from all different angles. The engineers will be delighted to see whether they can get the copter to fly. But even that will tell something about the science, because both of those things, and again, we've no idea really whether there's lots of how the air on Mars moves, and that's where the microphones come in. Again, Niamh mentioned everything at this stage, but by listening and by seeing how things move, the scientists can tell something, the engineers can tell something, and then when you combine all this together, it tells us more about the atmosphere of Mars, and it also tells us more about the sand or the soil or whatever, and so there's massive amounts of learning. So Ingenuity, to cut a very long response short, Mary, is basically the first sort of copter to go to another planet. And if it works, it's going to be done quite frequently from then on.
That is amazing. And Niamh, I have to ask you something. You participated in a mission. Can you tell us about it, where you simulated being on Mars? So tell us where that was and what it was like and what did you do? It was very
so can I share the screen? I've got a few videos I can show you. So let me just line that up. Yeah, so it feels like years ago now, but it had a profound effect on my life. So there are these facilities that are in extreme environments around Earth for people to research and conduct science in astrobiology, which is the science that's really been looked at in terms of searching for microbial life. That would be astrobiology. And they get a chance to be in the field and conduct experiments in landscapes or locations that simulate either another celestial object like the moon or Mars. So I went on one that simulated the landscape of Mars, and it was the Mars Desert Research Station in the Utah desert. Sorry, I'm just lining up my in the Utah desert, and we were there for sorry, I can't find my, sorry about this, Mary, I can't find my presentation, and we were there for that's why I haven't opened it. And we were there for just over 2 weeks, but it felt like forever, and we lived as if we were on Mars. So what that means is, you know, Mars is a very thin atmosphere, as we know now from what Niall just said about the Ingenuity rover, and there is a gravitational force which is very different to Earth. Now we couldn't simulate that, but there is no Tesco, and there's no there's no electricity board, and there's no water department, so you have to bring all those in, and because of the atmosphere being very thin and carbon dioxide, every time you go outside you would suit up. So this is the facility. You can see that the landscape in the Utah desert was selected because geologically it looks very similar to what we believe the Martian landscape would be like. So it's very high in sulfur and oxides, which is why the landscape there is red, which is why the same as what the thing of Mars. This was my crew. They were an international crew from Israel, Slovakia, Australia, France and Morocco, and myself, and we lived here for the engineers and stuff. This is a ground floor and a first floor plan off the habitat, which was 8 meters in diameter. But I'll keep going because I'm aware of that we're pressed for time. So some videos. This is what it looked like. Oh, excuse me. This is what it looked like on the outside. Sorry about this now. Oh, Niamh, what are you doing? So this is what it looked like on the outside. Let me just.
There you are, your Irish flag, good woman.
Yeah, flying the Irish flag. My videos are better than this. It's just that I had the wrong build settings on it. So that's what it looked like from the outside. So you have a 2-story building, and you have that's called the habitat, and then you have something that looks like a greenhouse. That's the green habitat, and you have a series of tunnels that link the hab with the green hab and the science dome. And the reason for that is that it took far too long to actually put your suits on. So if you were running between the two, it would you'd never get anything done. And then interior, this is the ground floor. Just bring the sound down. This is the ground floor. So everything is 20 years old. It's a bit broken and everything. Our spacesuits are signifiers for the fact that every time you go outside, you have to suit up. So they're not real spacesuits, but even that was cumbersome, and it really impacted and influenced your way of feeling that when you went outside, it was foreign, all your senses were cut off, and it was extremely uncomfortable to wear them for sustained periods of time. And then you got very used very quickly to being in this confined space, and even the fact that it was just over 15 days, you forgot about Earth very quickly, because we didn't have television, we didn't have internet except to send reports back and forth to mission control. We respected the time delay, which we also have to take into consideration when we're getting data back and forth from Perseverance and Curiosity. There's at least an 8-minute delay between sending a signal and receiving it onto the other planet. So we respected that. This is the upstairs. It's kind of like a kitchen, so that's fine. This was my bedroom or stateroom, which is, I just think it's hilarious. And I slept on top of this box. They kind of bisected the room. So somebody slept on the top of the box and somebody slept on the inside of that same box underneath. There was no room for me to bring anything apart from my media equipment, which I did. And I pulled the short straw. There was very poor circulation and ventilation in my room. So hot air kept us warm. And I remember waking up going, so many times. I was like dying of oxygen deprival, and also just incredibly thirsty. And this is what we ate. Again, another salty diet. lots of dried food, you know, which campers and people living on rigs and stuff would be used to. So that was dried eggs. So, you know, thankfully I don't have a very good palate, so I didn't mind that. Sorry, I'm so all over the shop tonight. Where am I? Yeah, here I am here. I'm going to just continue with this video and bring you further on to another. Niamh, sorry, this is terrible. This isn't like me, Mary, at all. I want to show you us when we were outside suiting up. My computer is really acting up tonight. Sorry about that.
That looked like a very heavy backpack you had on there.
It was very heavy, and it was a signifier for the spacesuit. It was extremely uncomfortable as well. Let's see now. Let's go back in here. And it was you never got used to it, and you would be so hot in the suit, and with the suit as well, the helmet would fog up, and it would be very see. Now let's just turn this down, and let's just go on a little bit further on this video. So no, I don't seem to have it. Oh, I'm sorry, I don't have another video. I don't know what happened. Yeah, that's probably enough to show you. But it was an amazing experience, and it changed my whole relationship with water. We take all that kind of stuff for granted, and I got so used to being off Earth. It was an incredible experience. So yeah, there you go. That's it.
Really, really cool. That gave us a really good insight as to what it's like up there. And Niall, I want to ask you a question. The 2026 mission, is it on track? And what are they going to do?
So that's a really good question. It's a really difficult question. So in 2026, the hope is that there would be a Mars sample return mission. So the idea would be that those tubes that hopefully Perseverance will drill over the coming couple of years will be returned. So the way it works, first of all, is Perseverance uses its long arm to drill down into locations that the other instruments on board Perseverance have identified as being likely areas that are of interest. Those cores are then put onto a carousel on Perseverance, and then when Perseverance reaches a location where they think they will be easy to retrieve it, they drop them onto the surface. It sounds almost crude in a way. So that's what happens. Then Perseverance continues on and maybe drills some more cores and so on. So Perseverance has a lot of really sophisticated new equipment on board, but it's nothing like the type of equipment, the analytical equipment that you can use if you bring stuff back to Earth. So the idea is that if we see some interesting things with Perseverance, that will allow us to take core samples which are really interesting, but we may not be able to answer the question, is this life or not? And that's a key question about this. So the idea is that rather than to send up an even more sophisticated rover in 2026, they'll actually just go and retrieve the samples. Now, what that means is we have to do something we've never done before, which is retrieve a sample from Mars and bring it back to Earth. We have retrieved samples from comets. We have retrieved samples from asteroids. So we can do this. It is doable. But we've never done it in this way, that you actually have a vial, which is a few centimeters long, which you have to pick up. So the idea is that the European Space Agency will build what they call a fetch rover that will be dropped onto the surface. It will pick up these devices, these tubes. It will then go back up to meet an orbiting Mars return orbiter, which will be in orbit around Mars, not surprisingly. That will then come back to Earth, and as it reaches the orbit of the Earth, it will deposit those in a canister back into basically North America, which will be where it will be retrieved. So that's the idea. So the question is it on track? Well, Perseverance is going to determine whether it's on track or not. So for example, suppose the worst happens and tonight it doesn't go well. Well, obviously there's not going to be a 2026 return sample mission, and that's going to be canned. So there's going to be a bunch of people very nervous tonight and over the coming weeks. What if the drill doesn't work? Well, again, you have nothing to sample return. So there's a period of possibly, certainly a number of months between here well, ahead before we really have any idea whether that's going to go ahead. But all of the preparations are continuing. There's a lot of work going on at the moment, but the final funding for that hasn't been released yet because we don't know whether or not that it makes sense, and so that it's not quite full steam ahead. That's also, by the way, Mary, why it's 2026. You kind of think, well, if Perseverance picks up tomorrow, why can't we be ready? Well,
Right.
you can't be ready for something if you know, and spend a lot of money if you don't know what you're being ready for. So we have to really wait to find out. So if Perseverance has succeeded, then we can really go ahead with the sample return. But it's a really good example of what you can do remotely, but what you can do back on Earth is always going to be significantly more sophisticated for the foreseeable future. So sample returns are going to be important for a long time to come before we can build really sophisticated instruments. And they don't mean in any disrespectful way to Perseverance, but you know, there's huge constraints on weight and size and all the rest. We don't have that. You could do an entire factory worth of analytical equipment back here on Earth if you get the sample back from Mars.
That's really amazing. And a question for you, Niamh, then. What measures are they taking to, obviously there's radiation, right? There's a lot of really cool equipment on board, and that equipment is going to be there for, we hope, 14 years.
Yeah.
What kind of measures are taken to make sure that's all safe and well and protected?
Niall, I don't know. Do you have the answer for that? I actually don't know what they're.
Well, yeah, I mean, I suppose
I don't know.
There's one of the concerns that people have is radiation damage.
Yeah.
From cosmic rays. So we're very fortunate on Earth that we have a magnetic field. Mars doesn't have a magnetic field, at least none that's appreciable. So the problem is that the dangerous radiation from the sun that gives us the northern lights is great to look at, but totally harmless because the Earth shields us. On Mars, that shielding doesn't exist. So one of the things, if you want to last for sort of 14 years, you don't want the cosmic rays to gradually just degrade your electronics. So it won't damage the materials of the arm or something like that. Those materials will be fine. Nothing significant will happen over a 14-year period. So it's always a concern about the electronics, and particularly things like the cameras and so on. Cameras use very sensitive electronics, and cosmic rays can do damage. But thankfully, it turns out that some of the standard technologies that we use are really quite resistant to radiation. So this idea of what we used to call radiation hardening isn't so important now as it used to be at one time. And that's not actually fully intentional. It just so happens that some of the developments on Earth to make devices more robust, make them more robust against radiation damage. So some of the things that do require a bit is that they've improved the wheels on Perseverance. Because ideally you want your wheels to be a little bit rubbery, but when at minus 120 degrees or something on Mars, depending on whether you're in the summer or the winter, whatever, you know, rubber can become hard, and then you just slip on things, and that has happened, and we've seen that. So it's making materials that stay a little bit rubbery and a little bit malleable, so they can kind of continue to grip in very low temperatures. So again, going back to the very early part of our conversation and keeping an eye on the time. You know, as we were discussing at the very outset, we've been doing this for 40 or 50 years. We've had 49 missions. Okay, this will be the 5th rover on Mars and so on. So we've learned a lot, and we're putting our learning into practice here, and we learn more from this as well going forward. So some is fortuitous, some is very intentional, but 14 years shouldn't be. I should be touching wood here, but I'm not superstitious. From an electronics perspective.
And you know, just look at how well Curiosity has survived as well. You know, it's incredible. Like these machines are built to last. So that's what's great.
Great engineering, great people working on them. Now, Niamh, I want to ask you about a book. You wrote a book about space.
I wrote a book about my own relationship with space and why it matters to me and why it's important, and it kind of chronicles being at a stage in life where I had the courage to kind of look back and change a few things and tweak life so that I could kind of devote the rest of my life to communicating space and talking about space and kind of really setting myself a life quest to see if it's possible for somebody to have this kind of ideal and objective later in life, what you can actually achieve in that time, and is it possible to make the impossible possible and actually get to space yourself and see the Earth from a distance. So the book is it's kind of like a memoir of everything that I've been up to since then. And yeah, I got an email this morning from the publishers. It's nearly a year ago since it was actually launched. Yeah, because we were supposed to have the book launch, and then the pandemic hit and none of that happened. And we had a kind of a one during Space Week in October, but it was nowhere near. You were going to go, Niall, and everything, weren't you?
I know.
Well,
I was very privileged to be invited. I think
yeah,
it's a
we had
fantastic achievement.
yeah, but it's written from a very personal perspective, Mary, and so I guess I kind of want people to get into my head and realize, like, you know, when you go on these missions and you witness a launch, or you go on a zero gravity flight, or the Mars mission that I just kind of showed, all that kind of thing, taking it from a very human viewpoint, so that you don't necessarily have to know an awful lot about science or space to be able to read it, but it kind of whets the appetite and hopefully makes people think about, I'd like to know more. That might kind of give them the steps forward towards that, you know. So that's it. This is it here. I have a copy of it, just
very, very good. And it's called
coincidence.
Dream
I
Big.
just have it here. Yeah, nearly a year old. Isn't that amazing? Yeah. So yeah.
And
that's what the
now
book's about.
I have a last question for you.
Make it an easy one, Mary.
Are there any? These are not easy questions. These people are
No, they're not. They're
amazing
great
questions.
Very impressed.
They are incredible questions.
Very impressed.
Yeah, I'm very impressed.
We have future scientists,
Oh
engineers,
yeah.
everything here.
Yeah.
So watch out, world, they're coming. So are there any EU craft flying around Mars at the moment doing some work? You know.
Yes, so there are a couple, and actually just before coming to that, and Niamh can chip in.
Yeah.
Well, but just to say that we have been talking about sort of NASA tonight, and we've mentioned the European Space Agency, and we've kind of mentioned SMART and all that. Anybody on this call who's young and who has a passion for this can expect to be part of these missions if they want to be.
Yeah, absolutely.
Their career. So there's nothing to stop that forward. So going forward, this is a very exciting landscape. It's not a landscape that's just over there. You don't have to just be, and tonight we're all looking, of course, we're all looking from a distance because the probe is going to Mars, but you can be part of this. You can be part of this exploration. You can aspire, and you can actually make it happen. So it's gone back to sort of Niamh's book about dream big, but these are realizable dreams. These are not sort of dreams that can't be met. So it's a really exciting time. There's more and more missions like this. That we're going back to the moon. There's more opportunities for Irish and global citizens. Obviously, Irish people. I know there's people from at least locations that we've seen tonight here. So just to make that point, because I think people go away thinking, oh, NASA are doing this, and this all gets done by NASA. It just gets done by people who are determined, and that's including people here. In terms, there's the Mars Reconnaissance mission, which is currently flying around, which will act as which has a key role because it acts as the gateway between the Perseverance and back to Earth. So the antenna on Perseverance. We mentioned 110 watts. So there's only a couple of watts of that. It actually is to power the radio antenna. And so that really will be very difficult, not impossible, and some of it will come back directly to Earth. But if you want to get the high resolution images and all of that really good, well, it's all good stuff. If you want to get even the stuff with the very good images, or this thing we haven't referred to much tonight, but this spectroscopy where you determine what chemicals are present. You really want to make sure that you have a stronger signal, and the way we get that is to use a repeater, and the repeater is the Mars Reconnaissance, which is a really smart thing that was put up with the intention of supporting row. So I don't know, if you can remember how long it's up there, but it's certainly up there. 5 years.
I know. Yeah, and it helped them, and it's been sending back images of the Jezero crater in advance of the landing site. So ESA have been working collaboratively with NASA for some time. Anyway, go back now. Back to you.
No. So exactly that's what I think. This is really good thinking. Again, it's about you know, we've been doing this for 40 years, so we thought sort of 5 or 6 years ago, well, how, or actually more than that, but how do we help Curiosity and Spirit, those two other rovers, for example? So again, they have the same problem. You can't beam directly back to Earth, because if you do, you need so much power that you need to bring a huge nuclear reactor with you. That's very heavy. That makes it even more expensive to get to Mars. So you don't do that. You do it by using a spacecraft which is in orbit, which acts as a repeater. So that's kind of the key. That's the key one that's in orbit tonight. That's the key one that's going to actually help Perseverance to communicate the really critical data. Can I just say on that, actually, these nuclear power devices, they've been around with us for a long time. And there's two spacecraft, which some of you may have heard of, Voyager 1 and Voyager 2. These are the two most distant objects, I think, in that we have sent out. And Niamh has I know, particular connections. So they use nuclear power because they're so far from the sun that there's just really, they wouldn't be able to work at all without this, but they're still sending back data 50 years on.
Yeah.
And it is amazing. But because they don't have a repeater, the power that they get back is very low. And because the power is very low, the amount of information they get is very low. So it's almost like, you know, if you greet people, you say hello and all. This doesn't do greeting, it just says 20, and that's me.
That's it. That's all I'm doing.
Yeah. There's no social niceness about Voyager anymore. It just gives you the bare minimum amount of information. With Perseverance, we wanted to be more colourful. We wanted to give us the full amount, and that's why we need a repeater in orbit. And so it's yeah.
And you know, what's really, once they turn it on, were you reading this now? What I find really interesting, so it's kind of just in its, you know, turning it on phase, check phase. The scientists are following the day on Mars when they, you know, once it engaged. So that's the difference between a day and a sol, right? So because Mars is like 39 minutes longer than a day on Earth, the lads like have to follow the day on Mars. So basically, you know, Sol 0 is the same, right? So you get up at the same time. But as the weeks are going to go on, they're going to be getting up in the middle of the night when it's daytime on Mars, and in order to collect the data. So you forget these distances, and you forget like the ingenuity that, you know, even the European Space Agency, do all these people involved in planning missions, which take 10 or 20 years to see happen. That's what I find amazing, that everybody thought about, right, you know, when Mars and Earth are close, that's a really good time to launch craft to Mars, right? So then that's the launch date. So then they go back maybe 10 years to plan in advance of that. And then, you know, so these are the minds of hundreds of people over generations. Like, you're lucky, as Niall said, for the majority of the people, they'll be involved in one mission for the duration of their career. And some of them don't even see it, you know, so that they're in the planning phase, and then they never see the implementation or the data coming back because they've moved on, they've retired, or whatever it is. So everything about space is about looking at the long game, and it reminds us of how incredibly small we are and how we have to collaborate as space agencies, and also as these private companies coming in. So reiterating what Niall said, you people looking at this tonight, and young families, the European Space Agency is doing just as exciting as space missions as NASA is, and the planning phase of them now you'll see at my age, 28. When you, what are you laughing? You will see.
You're not 28. You're not.
I just turned 28. Yeah. So my point is that you, when you're at this phase in your life, you will then be hearing about these amazing missions, and you'll hear about it for the first time, but actually somebody right now is planning those missions. And it could be you, or, you know, in 10 years time, planning missions that at the end of your career you will see come to light. And that's what's happening at the European Space Agency, as well as NASA and the Canadian Space Agency and the Japanese Space Agency and the Chinese Space Agency and Russia, and even the United Arab Emirates, and Ireland even is developing its own space strategy, right, Niall?
Yes, well, I was going to say, let's not forget in the future the
Irish Space Agency.
And, let's plan for that.
Yeah.
Well, I think we've seen tonight that we have incredible future ahead of us. Look at these wonderful people with all these fantastic questions.
Yeah, amazing
And
questions.
I think we might wrap it up there. And I want to say a huge thank you to Niall and a huge, huge, huge thank you to Niamh for sharing all your experience with us. And earlier on today, everyone here got a pack, a landing pack. And in the landing pack, there are some bingo cards. So as you can watch and listen to what's happening, you can mark all that off. And there's recipes for your Mars bars. Niall, also going on this after. And you can share all of these pictures and whatever you're doing tonight on social media. And if you use that hashtag, hashtag NSC Mars, you might get a prize. And the prize is Niamh's lovely book and also a huge big puzzle, a Mars puzzle. And I just want to say thank you to everybody who's here tonight because we are so excited. And it's been just wonderful. And thank you to everybody for making tonight happen. And Sabrina especially, who's running all this on the back.
Yeah, it's been great. It's gonna and what a night we have ahead of us, and fingers crossed that we have a nice soft landing. And thank you, Sabrina and Mary, for inviting myself, and I'm speaking on your behalf now. No, sorry for
watching the landing later on. And in the chat now, we'll put in where you can go to watch the landing live, and you can do your puzzle and your bingo card and your colouring and have a really, really wonderful time.
Yeah.
Thank you.
And listen, thanks to everyone who came along to listen in. And I also hope that the excitement carries, because that's actually what keeps all us going. Ultimately, it's the passion for what you do keeps you going. So, and it is an exciting night. It's a great night to exist. So we keep our fingers crossed that all goes well.
And maybe after tonight, we're going to have some other names on the next.
That's right. Just go on the website. Yeah. And I think it's the same for a lot of ESA space rovers as well. So, keep an eye out. So, yeah.
All right. Good night, everyone. Good night, Mars crew.
Good night, everyone. Thanks a million. Thanks, Mary. And thanks everyone. NSC, National Space Centre. They're just the best, by the way. So thank you for all of that.
Thank you for
Good night, everybody. Thank you for joining. Night now.